I will say one thing, and that, well, I'll probably say a lot of things today, but I will say that you have to start getting out of the habit of, I need 3 hours the night before for it to be even possible for me to pass the test. Got to get away from that attitude. Okay? You certainly don't, if you're going to go run a marathon, you don't the night before go out and run 25 miles just to get ready, do you? Right? Same idea. Of course not, thank you. If you're going to be ready for a marathon or a physics test, you're going to have to do the miles ahead of time, and you're going to have to do the work. Okay? I gave you yesterday. I'm going to give you a lot of time today. You've got Saturday. You've got Sunday. I understand that. I understand that. Okay? I get that. Okay? You will find the time. Okay? If I continually put off tests, then that just means we don't get as far as we need to. The other option is me just going on, and I know people hate that as well. Okay? Get yourself ready. You'll be fine. Okay? All you should really need to do Sunday night is maybe spend 45 minutes just going over stuff. I got this, no problem. Okay? If you are learning it Sunday night, you've got a bigger problem. Absolutely. Half-page cheat sheet, single side. Thank you for asking. Okay, so how about I spend a few minutes and at least remind you of what we've done this unit? How about we do that? Can we do that? Now you can choose to write this down, or you can choose to just sit and watch, because I'm going to post it to Schoology right away. It's entirely up to you. Okay? But these would be the things that I would expect. There really isn't a whole lot, you guys, because I spent a couple days just sort of, getting to know you a little bit. I would expect you to know what physics is. I gave you a specific word definition. No? I would expect we had some knowledge, skills, and attitudes that we talked about. Why is Connor talking back there? We talked about some attitudes and some skills and stuff you need to do. Really, I mean, it's pretty much common sense, isn't it? Like, are you going to come in with like a, I can't do this kind of attitude, or are you going to come in like, oh, just tell me how to do it. I'm not going to go and try and figure stuff out on my own. I mean, really, it's pretty much common sense. Okay, then we got into graphs, right? And we spent a little bit of time talking about graphs. Okay, so what would I expect you to know about graphs, do you think? Well, what I need you to know, I'm just going to go in through my binder here. Would I expect you to know the magic number of 3.6? Converting kilometers per hour to meters per second and back? Probably, although it may not come up this test. But that's still something you need to know. Still something you need to know. Okay? Alex, maybe you should, So yeah, you might want to have the 3.6 number down. You need to know which way, whether it's multiply or divide to, right? To go from meters per second to kilometers per hour is a? Meters per second to kilometers per hour is a multiply, and the other way is a divide. Right? When we talked about graphs, we talked about independent and dependent variables. Independent and dependent. You should know sort of what they are. The independent is the one that you manipulate, right? The dependent is the one that you sort of measure. The dependent is the one that you measure. On a graph, the independent generally goes down there, and the dependent generally goes there, although there are rare occasions when we flip them to make the slope make sense. Will I expect you to be able to make a graph? Yes. Do you need to study how to make a graph? I would hope not. I would hope not. Will I expect you to know the different types of relationships, linear, quadratic, and inverse? Absolutely. I would certainly expect that. Under linear, am I going to focus more on linear ones? Likely, because things tend to be linear, and plus we know more about linear stuff already, right? Do you guys know how to find the slope of a curve yet? You might, but I haven't really talked about it in class, and certainly we haven't done a lot about an inverse, so the focus is likely going to be on linear ones, right? But you should certainly know what the other ones look like. So under linear, will I expect you to be able to find slope? You know, using rise over run. Do you think I'll expect you to do that? Absolutely. Will I expect you to know the meaning of slope? And we struggled with that on that lab, unfortunately. Okay. Even though it was exactly the same as ones we'd done in class already. How do you find the meaning of the slope? You take the quantity of the y and you divide by the quantity of the x, and you have to sort of know what that is, right? Like, for example, we got a reaction time, right? One of them was density, because it was grams per cubic centimeter. We took the units. That's another clue to what the meaning of the slope is. So what are the units measured in? Okay? Just wondering what you're calculating there, Larissa. Oh. Okay? So yes, will I expect this? Absolutely. There's only so many things I can ask there, really. Okay? Will you have to be able to find? Yeah. Y over x. It's always y over x. Yeah. Y over x. Will I be able to ask you to find slope and y-intercept? Yeah. And we had some exercises on that. And if you didn't do them, then now's the time to do them. Now's the time to do them. You should certainly know positive slope and negative slope too. Okay. Will I expect you to, like, given a graph, be able to read the graph? Like, given an x, find a y, or given a y, find an x? Yeah. Do you need to study that? Do I even need to write that down? You just need to know that, right? I mean, you should know. You know how to do it. Anything else with graphs that you can think of? I might ask you to do something on the computer too, right? I might ask you to find a trend line on the computer, because we did do that. Okay. Okay. Yeah. 2012. Yeah. Yeah. That's the year. That's the year. Okay. And then we got into some stuff about models, laws, and theories, right? I'm going to go to another page here. Models, laws, theories. And I would expect you to know what each one of those three things mean. Okay? Or at least be able to identify one, maybe give an example of one of them, right? We spent a couple days talking about that. Examples of models like the Bohr model, solar system model, right? Models evolve over time as we learn new things. Laws are what? Don't you dare say are proven theories. They're not unproven theories. What's a law? Something that we see happen over and over and over and over, right? It's something that we observe to happen. It's a predictable pattern, is a law. When we see this, when this happens, when this occurs, then this occurs. This is the result of that. That's a law. A theory. Is a theory something that hasn't been proven yet? Please don't say yes. What's a theory? About what? When you say that, Brian, that leads me to believe that you still believe in this. Remember what this is? Hypothesis, law, oh no, sorry, hypothesis, theory, law. Is that true, Brian? We go from hypothesis to theory to law? Not really. What did the guy say, the guy with the funny accent? Rubbish. Rubbish. Garbage. Not true. Not true. Laws are not proven theories. Theories are, there's two kinds of theories, right? What's that called? A spectrum. Remember theories? There's speculative, was the word that I was trying to come up with. There are speculative theories, and then there are robust theories. And definitely, if there's one thing out of that whole bit about models, laws, and theories that you need to know, is the difference between a speculative theory and a robust theory. Anybody want to take a stab at it? What's the difference? Can you give me an example of a robust theory, maybe? Or what's a characteristic of a robust theory? It has lots of evidence, Most people believe it's the true explanation, right? Lots of evidence, generally well accepted, right? It's just sort of accepted as fact. That's the way it works, right? A speculative theory might be something that's what? Not quite as much evidence, still some disagreement over how true it is. What would be a real good example of a theory that is still currently speculative? Maybe it shouldn't be, but it might be global warming, exactly, or climate change, right? Still lots of people that are a little bit speculative, a little bit skeptical. They don't believe the evidence. They say there's not enough, okay? Robust theories are things that clearly have been investigated for a long, long, long time and are generally accepted as true. You definitely need to know that. Theories are not proven, are not unproven laws. Okay, laws are just something that we see observed happening. So you might need to do a little bit more reading and thinking about that. Okay, and then after that, I think then we got right into vectors, did we not? Oh, law of parsimony you should know. I'll just stick that one in here. Law of parsimony, which says what? Say again? Simple is better, yeah. The one that has the simplest explanation, the one with the fewest assumptions, the one that is sort of, yeah, that just sort of makes no sense. It's likely true. And then we got right into the vector stuff. And I sort of reviewed the vector stuff yesterday, right? I don't think I need to do that again today. Flip that sheet over. Let's just do a little quiz here. A little fun, completely fun, not for marks, completely fun.